This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 85. Doug Oatis shares an update on what is new for Ansys Additive Suite and optimization, along with news and events from the world of Ansys. Welcome to April. My name is Eric Miller. I'm one of the owners here at PADT and your host for these podcasts. I'm recording this on April 2nd, which is 1 year and 1 day since PADT went into lockdown in Arizona. We've been back to voluntary return to work for some time with strong social distancing and masking and all those rules in place. But every week, a few more employees reach that fully vaccinated status and come back to the office full or part-time. So it's good to see people around. I myself, like me, I'm recording this from my office at PADT. You can probably hear the air conditioner in the background. It's been missing for a year at our facility here in Tempe. And it's kind of nice to be here in the office. I'm about 4 weeks out or 3 weeks out from my vaccination. So second shot. And so I've been in the office this week. So it's been nice and to see people's faces in 3D instead of on a 2D screen. We still have a way to go, but it's good to be on this side of the curve. And we're staying busy here at PADT. So one of the things I want to talk about before we get into our discussion is that we're hiring. First of all, looking for an account manager, simulation software sales in the Bay Area, California. So if you are interested in sales in the Ansys world, we are hiring there. We're also hiring for a account manager here in the Tempe office to help cover more of Arizona. In addition, we have 2 openings for antenna application engineers. So these are engineers who know HFSS, specifically in the antenna application area, both for here in Tempe as well as in our Littleton, Colorado office. And then one of my departments has 2 recs out. These are more design, product development, and simulation consulting. So this is really working in the consulting team. The first is a kind of a new position. It's called Customer Success Engineer. It's something that all of our engineers have done part-time, but we want somebody really focused on that. It's somebody that really is kind of the interface between the engineers and the customers and make sure that they're communicated with and everything's going great. And then we're really looking for a product development engineer as well. So this is a experienced engineer with a lot of different skills. CAD, test, design, problem solving is the most important, project management, all those sort of things. So if you've done product development in any industry and you're interested in joining our team in Tempe, please do reach out. You can head on over to padtinc.com and at the top click on careers and you'll see a full list of all of our openings and positions. I will note that we are an ITAR compliant facility. These are jobs here in Tempe. And so all of these positions do require a U.S. citizenship or a resident status. So people that might be from other countries that are interested, sorry, not this time. Hopefully we'll have some openings in the future that might allow that. Let's jump right into our discussion today. We're joined by PADT's very own Doug Oatis, who's been on this podcast many times. He's calling from his home in Colorado. He's not quite back in the office yet. And we're going to talk about Ansys Additive Suite and optimization at 2021 R1.
Another discussion with Doug Oatis in Colorado about Ansys Additive Solutions and some optimization stuff. How you doing, Doug?
Good. How are you?
Doing great.
You're actually back in the office now.
I'm in the office, so it's official.
Living the dream.
Living the dream. I'm back. Nobody cleaned it while I was gone, so it's just as messy as it was a year ago when I left it, and maybe a little bit more dust, but still a lot of knickknacks and crap in the background. But if anybody's ever seen my office, I tend to collect a lot of little things, and they're kind of behind me. That being said, collect and hoard, but yeah. So I can give it. I'm not hoarding. I can get rid of some of it.
There you go. Retirement fund.
That's right. I'm gonna eBay it all when I retire. So we're going to talk today about one of our favorite subjects here at PADT because we do, as those of you who listen regularly know, we not only do Ansys, but we also do a lot of additive manufacturing here. So the ability to use Ansys to model additive manufacturing has been a lot of fun and excitement for us. So Doug's going to lead us through. It seems like this release was mostly under the hood. There's some important stuff, but it's not as big, user-facing improvements that we've seen in the last couple of releases. Is that a good assessment?
Yeah. I mean, I would say, there's no like brand new feature. Like everything is typically like, either an addition to an existing, like a slight modification or like an expansion of, something else. So, I say that, one of, the updates was actually removing the beta tag from one of the additive science products, which we'll talk about, which is a pretty big thing, obviously.
Yeah.
But yeah, no new toys. The toys just, I guess, work better.
That's what we're to put. No new toys, but the toys work better and have more things to play with on them. That's good. Yeah, or better ways to play. So let's start with additive. What's your favorite new capability that they've added at this release?
Well, I mean, I think you first have to like step through the product suite because there's optimization could be part of additive, but it's also kind of process independent. But as far as additive, you kind of have to step through each product suite, and it's primarily focused for anyone that's not familiar with this at all. It's just powder bed fusion. That's the primary user base here, and so you have a tool called Additive Prep, and so that is that sits within SpaceClaim, and it's there to essentially help you put your part on a build plate and actually generate a build file. And so, the new at, 2021 R1, I'm going to fall over that several times.
Every one of these we've done for 2021 R1 and we've stumbled over.
Yeah. So, the big thing is, being able to write EOS and Renishaw build files. So actually being able to, write the file that actually is sent to the machine and build it. And, so, kind of one-stop print shop from that.
Right.
But beyond that, so Additive Prep, in addition to actually generating the build file, the slice data and the scan data, it has the ability to kind of guide you in, how should I place my part on my plate? And it's not actually solving anything. It's not solving an FEA, a thermal, any type of voxel-based simulation. It's more of a rules-based kind of, it's basically like instant vector math.
Yes, exactly.
So, it kind of gives you a color map based off of the orientation and what you're what's most important to you. And so kind of those most important to use, you had essentially three to begin with, and it was, the build time, the tendency of it to distort, and how much support material you're going to need. Right. And so new at this one is a cool feature. It basically tells you the shadow. So if you're trying to fit as many parts onto your plate as you possibly can, you want to make sure that you're consuming the least amount of real estate, that the shadow underneath your actual part is minimal. So kind of a nice way to look at placement based off of the shadow, and then also looking at the stair stepping. So essentially, layer by layer as any type of angled surface relative to the build direction, looking at that.
Yeah, I like that. The visualization is really kind of handy, and it's when we teach the design for additive class, we talk a lot about those things. But until you built a lot of parts, you can't just look at something and say, "Oh, this is going to have bigger stair steps," right? This is really useful. Yeah.
Yeah, and I mean, stair step is, it's similar to running a simulation off of a printed part. It's not just giving you the answer, but it's also telling you like how much post processing am I going to have to do in order to get this to meet whatever spec I have.
Right.
And the other thing is the ability to generate this color map of that tells you how you should orient it relative to your build direction is faster. So always a good thing.
Oh, good. Yeah. Faster is always better. Yeah.
Right. Yeah.
And correct me if I'm wrong, but we're talking about additive prep, and that actually resides within. You said this. It resides within SpaceClaim. Yeah.
Correct.
Yeah,
Right.
which
So
is
you're
good
right.
to know. Yeah.
Yeah.
So I think a lot of people don't realize that it's in there. So it's pretty cool tool, and it's going to get better. These are small changes, but under the hood, I know they're doing a lot more that'll show up in future releases. So
Yeah, I
and
mean,
mhm,
Space Claim kind of jumps into this additive world in a couple different directions. So, from the topology optimization side, it's
mhm.
involved on the back end. On the printing side, it's involved on the front end.
Yep. Yep. And we here at PADT have an EOS M400, so I'm glad to see that that's in the list. So I'm happy.
Yeah,
All right.
the only thing to realize is generating a build file for the EOS or the Renishaws. You actually have to have a license
Right.
for whatever the EOS print and the Renishaw licensing scheme. I won't pretend to properly appreciate those,
Mhm.
but a license has to be available. But beyond that, you can have multiple machine configurations. You can edit those and change around a whole bunch of things.
Cool. All right, well, let's move on to the next product then.
Yeah. So,
Which
and then we
is
get to
additive print, right?
the formerly, I'll kind of group them together: additive print, additive science. The formerly 3D sim. It's been long enough that they should just be additive print, additive science in everyone's
Yes.
mind.
Yes.
These are the outside workbench. This is not a workbench-based product. This is a standalone, primarily intended. Additive print is if I have a machine and I can tune my my simulation or tune my analysis to the actual machine that I have on hand. And really intended for you don't have to worry about meshing. It's voxel based. It has distortion compensation, all sorts of stuff. The thing here is in 2021 R1 they added some documentation and some theory reference just to kind of show you the boundary conditions and what they're trying to do. So always a good theory is good. Documentation is always good. Just especially when it includes pictures. I guess I'm a picture guy, so I'll always appreciate that. And then on the additive science, so this is the exact same interface. So the additive science is really more for tuning a machine, playing around with different parameters. What does it actually do, from a process standpoint? So evaluating, melt pool dimensions, looking at porosity or any type of manufacturing induced defects. And the big thing that I had previously mentioned, the microstructure, where you're actually, predicting what the microstructure is on the surface. That's the beta tag is off on that one, and so fully supported for 3 materials: Inconel 718 stainless steel and the alphabet soup aluminum.
The alphabet aluminum, the aluminum with other stuff.
I was talking my way through it. And so, those are the big things, and just kind of a retuning of the material properties, just based off of recent testing.
I think it's really important if you're new to the additive suite that Ansys has, not just what's new in this release, but additive science has the potential to be a real game changer in that it's actually looking at the shape of the microstructure after you melt and solidify with the laser, right?
Right.
And the fact that the microstructure product, which is really difficult to do, is out of beta means it's past quality assurance. And I think that's what's been taking a while, because in order to pass quality assurance, they got to do actual physical testing and then compare the results to the physical testing. So that's very encouraging.
Right.
And definitely if you're interested in that. So that's, instead of building these things and slicing them and looking at them in a microscope and taking pictures, being able to predict this stuff and then change some of your parameters on the build side, on the machine side, the virtual machine side, to get some different microstructure behavior in a virtual way is going to be a huge time and money saver. So if you're interested in that, do reach out to us, because we're learning as well with this tool and using it with our machines and some of our R&D we're doing for customers, and it's pretty cool stuff. I'm pleased to see it get out of beta. So
yeah, and from taking a step back on what do you actually do with that? And so you can kind of start to see that this can govern what type, fatigue and additive and metal printing is kind of a sensitive topic. It's like fatigue and composites, but you can kind of use this to understand, what does that structure look like? What would that do for any type of cyclic loading that I might have? So it offers some additional insight to, how the machine parameters, how it may affect downstream or actual part performance. And kind of same thing with, doing any type of thermal relief or, any type of, heat treatment. What does that do? What type of creep law could I match relative to, whatever the grain structure is? And so, you can kind of see it opens up the doors to, some more fine tuning.
Cool. I'm excited. I've been excited by that since it came out. So I'm glad to see it move forward.
And the other thing on the additive science is opening up the range of input parameters for the machine. So it used to be kind of hard coded, limited on the cooling rate or some of the other machine specific parameters. It's only considered a narrower range of values, and so those have been expanded.
Which I got to give credit to the vendors. They were kind of like, this is our secret sauce. We don't want to share it with you. And I think they've realized that their users want to know what those things are, and they've shared it with Ansys, and it's been really positive.
And I'm going to jump back to the additive print because I realized I completely botched one of the things I wrote down. So additive print can read in a build file. And so it's, each rev, you see more machine support. And so there's 7 different machine manufacturers that it supports. And so, it's not just EOS and Renishaw, it is Sysma, SLM Trump, HP3D, and Additive Industries. So the ability to read that in and run a more detailed simulation off of what you're printing to evaluate.
Let me explain that, dig into it a little bit deeper for those that aren't familiar with some of the terminology. If you're not a laser powder bed fusion person, the way these machines work is a given layer of powder. We take a laser and we draw on that top layer, and it melts the powder, and then the powder solidifies. So you can get pretty damn close just saying, I'm going to melt these regions with on this layer, and get some useful information like thermals and what your residual stresses and deformations are going to be. It's not that inaccurate, but if you really want to get into it, especially if you want to look at microstructure, what we call the scan path, what pattern does the laser follow? That's critical to getting those more detailed things, and that's what we're talking about when we talk about build files. So you go into your machine, you program all the layers. Now we take what the laser is going to do and read that in, and it's pretty important stuff.
Right. Yeah, you play around with the laser width, the power, the left to right, right to left, up to down, that kind of stuff.
Do you randomly move around the build area and do 1 inch squares, or these are all European machines, 1 centimeter squares, or do you start at the top and go to the bottom? There's a lot of these things that you can define in these machines, and so once you've defined them and it calculates the beam path, and that's going to impact, that's to take it to the next level. To see more of those machines, and to be honest, the majority of them out there are EOS and SLM, and those are the top 2. I want to say GE is number 3 or Renishaw is number 3. I can't remember which. So they're hitting the big guys. Well, hope to see GE in there next, which is former Concept Laser. All right, so very cool on that. Anything more on those ones, or you want to move to Workbench Additive?
No. I think I'm gonna push this along just because I know there's a lot to discuss, so it's actually kind of a nice segue to the Workbench Additive.
Right.
And so now talking about additive print, additive science, those are outside of the Workbench environment. And so inside of the Workbench environment, you have the Workbench Additive toolkit, tool suite, whatever you want to call it, which is essentially solving a transient thermal simulation, coupling that to a static structural. So it opens up all of the, mechanical APDL material models and all of that kind of stuff. So it offers you, a bit more flexibility in playing around with, what's part of the plate, what's being built, what isn't. And but the difference here, and we were just talking about build files, and so investigating, the scan direction, what that does to the thermal stresses and strains that develop. So Workbench Additive doesn't necessarily account for scan data. It's more of a layer by layer basis. So it's kind of assuming that you have your machine tuned properly. You're not keyholing or anything like that. So it's kind of a more holistic approach. And primarily, the user base here is like, if you're, I don't want to say new to additive, but if you're investigating, can this be printed, rather than can this be printed on this machine? So those kind of different questions. And so Workbench Additive, there's one of the things that was that's been kind of jumping around, and was originally introduced as a command snippet, then it became a contact object, and really it's now its own separate tree object in the connections branch, and it deals with it's called the AM bond. I believe that's the APDL command. I'd have to look in the documentation.
I think that's correct. Yes.
It's the way that you can use an STL representation of your support structure, and it's how we connect that to typically a layered tetrahedron mesh. And so layered tetrahedron, so initial release of the Workbench Additive, everything had to be hexes. Then this layered tetrahedron, where it's a mesher that builds up a tetrahedron in a layer by layer basis. So that way, as the solver works, we can turn elements on or off, or I guess turn them on, as we build in the build in the Z direction. And so you kind of key the element height and kind of keep that consistent layer, so that way you can track what happens on a layer by layer basis. So that AM bond is now a completely separate object in the tree. And then the other the layered tetrahedron mesh has I'll be honest, I've struggled with using it at times with complicated geometry. So there've been some new kind of program defaults that should simplify the setup and make it a bit more accessible and a bit more less not intensive, but intimidating. That's the word I was looking for.
Yeah. It's for those that aren't familiar with it, the layered tetrahedral is basically a tetrahedral element where you can define a local coordinate system and then define layers along the Z direction in that coordinate system. And it can get messy pretty quick.
It's if you've ever used like the patch independent mesher, it's one of these where there's a lot of controls there, and I've taken to whenever I'm teaching a class and showing everything, it's saying you don't have to use all of this, like you don't have to use all of these, but on the layered tetrahedral, it used to be you'd have to play around with a lot of the different settings. So program control should help, but the biggest thing is on the post processing. And so one of the things you look at when in these powder bed fusion is the recoder interface. So essentially, as I'm printing and I'm moving my recoder that essentially spreads the new powder on a layer by layer basis, as I'm printing, am I going to grow into my recoder? Am I going to have to worry about, having to, and depending on if you have a rigid or flexible recoder, this can mean, damaged recoder or damaged machine. And so, anytime that you do that, you can kind of kiss that entire build process goodbye. Right. So however long you were running the machine, that's lost money. So recoder interface, that used to be an ACT extension, and the post-processing was less than fast.
It's complicated.
Yes. Because essentially has to interrogate the entire model and look at a layer by layer, build direction growth, and then compare it to an allowable, and then give a margin essentially. So the post processing has been improved and it essentially writes its own separate file now.
Nice.
To more quickly post process. That, and then it also includes a layer end temperature, essentially giving you a hotspot readout for, as I build this up, could this potentially be a problem where, I either need to slow the build speed down or, add some support to get the heat out, that kind of stuff.
Love it. That's very useful. So they're getting into, solving real world build problems here.
Yeah,
That's good
and
stuff.
The other cool thing, so in the Workbench interface, it runs a wizard, so kind of walks you through the setup to kind of make it a bit easier. Because we're operating in Workbench, we can also use other tools, and so if we're trying to calibrate, some stress scaling factors. So this is typically used for more kind of quick simulations to validate canvas be printed, and the stress scaling factor can be tuned to a specific machine. We can plug that in, and the wizard will actually walk you through and create an optimization routine until you can identify, if you have most calibration prints are, cantilever beam or, some fairly basic shapes. But, if you have, something that you've printed that the distortion in any direction, so it doesn't just have to be in the build direction. You can walk it through and, actually run an optimization to have it try to figure out what should the stress scaling factor be in order to obtain, the coefficient of the right answer.
Very, very useful. Yeah, and that you do have to calibrate these things, right? So
yes,
yeah, that's really important.
Yeah.
Cool. So
that's it. That's it on the additive.
That's additive. So that's good stuff. And very useful for people using it. And as always, if anybody has any questions about any of this stuff, and what we're going to talk about next as well, do reach out and we can point you in the right direction. Ansys is very committed to improving their additive tools. And in my opinion, the work they're putting into Space Claim to add pre-processing capabilities in there is fantastic. And I won't get into the religious wars of pre-processing for 3D printing, but there's one company that's kind of dominated that for a very long time, and it'll be nice to break our dependency on that monopoly. So it's good stuff. Okay, let's switch gears completely and talk about the what's new in optimization.
Topology optimization.
It's topology optimization, yeah.
Yeah, and I guess now it's not even topology optimization because there's a shape optimizer now.
Right. It's all built in, together.
Yeah. So, to simplify this down, topology optimization, if you're unfamiliar, this is essentially I give the solver a block and some boundary conditions, and then it whittles away to meet whatever objectives and constraints that I've set, in addition to manufacturing constraints and a whole bunch of other stuff. Whereas shape optimization is I give it the starting shape, and then it actually distorts the mesh in order to meet the exact same objectives and criteria. So from a pre-processing, feeding analysis environment into your topology optimization, you can now use joints. So if you don't use joints, I use joints all the time. It's a pretty nice way of, I almost call it like a linearized contact, but it's a nice way to add, rotational degrees of freedom, or, create the proper load path. So that way we're optimizing off of the correct, load path.
Yeah. It really opens up the door. In the past, when we were doing topological optimization, we almost had to pick the part we wanted to optimize and use our full Ansys model, say the existing design, to come up with the loads to apply to the part itself. With joints, we can now do some pretty cool assembly stuff. Yeah.
Right. Yeah. So you're not kind of limited in, basically the more options that you get a more realistic output for topology optimization based off of a more realistic input for the loading condition. So more options is better.
Yeah, garbage in, garbage out. So this gets rid of some of the garbage. Yes.
Right.
Good. Okay, what else?
And then so the ability to use stress, a stress criteria. So it kind of allows you to, the optimized shape that you get out of it, basically builds in your fillets for you. So you don't have to put those in. And so you can essentially have that as a criteria. And then on kind of the flip side, so typically, the basic optimization solution is typically, a compliance base where we're essentially trying to just, reduce or maximize the strain energy. And so you can now actually define a constraint on the strain energy. So that way you kind of can set a bound of like, thou shalt not be weaker than this.
Right.
I kind of view that as more of like a more experience level control, because you have to be comfortable with what is strain energy, and do some additional work up front in order to understand what does this compliance mean relative to my structure. But it's a nice introduction of anytime that you remove a limit, and that's a good thing.
Yeah. It's when we're really moving into getting more towards the solution we want, right?
Yeah.
Rather than, well, this is what I can come up with, but really dialing in. And if you do take a look at some of the examples that Ansys has, and if you listen to the webinar that Doug just did, or take a look at some of the other material on it, you can see the parts are looking less funky. And I don't know how to quantify that, but it's like, I gotta go in there.
Less funky.
Yeah, I know. I'm looking at the original, the way it would have optimized, and I know that I'm gonna have to go into my CAD model and fix a few things, right? It's coming up with shapes that kind of deal with that geometry on its own.
Right. And at the same time, I don't think I'm in that I'm always going to be in the mindset that this is always going to be a guide. And it can be a really good guide and get you 99% of the way there, depending on the use case.
Right.
But at the end of the day, Skynet is not going to print itself.
That's right.
We're safe for a few years, and so yeah. I mean, there's always going to be some guidance, but yeah, the ability to have multiple loading environments, play around with a lot of different settings, your own constraints. And it's a nice way to so to hit on a couple of those. So one of the reasons that the output looks a little cleaner or a little less work intensive on the post processing side is that at least on the density, the SIMP solver, there's what was beta as far as how we filter out elements to keep or remove. That's now a nonlinear filter. It's been fully released, so
good.
That's now the default. And so if and then to hit on the more expert level parameters, the ability to kind of play around with the initial volume fraction. So this deals with kind of I don't want to say that we're kind of differently seeding the model with holes, but it's a different way. If you have a highly nonlinear response to all of your boundary conditions to what the optimized shape is, you can play around with this and get some more, a different output based off of how you initially seed the model.
Okay.
So again, just more, this isn't something that everyone has to use. It's just something that if you're comfortable with the underlying math, and maybe me saying that indicates that maybe I'm not comfortable with the underlying math, but it's one of those, I'll call it like an expert level parameter.
Right. And really getting to a more optimal design and a more feasible design maybe out there. Yeah.
Yep. And then just to hit on a couple other things. So, one of the things that we can do in an optimization is specify some manufacturing constraints.
Right.
So this isn't necessarily specific to additive. Like you can, this can be a casting operation. Right. This can be whatever. But for the overhang constraint, now this is specific to additive. It used to be, you could only do the global Z and it had to be your entire domain. Now you can play around with the orientations, play around with the user-defined coordinate systems. And then one of the constraints is an extrusion constraint. So making sure we essentially maintain the same cross-section in a user-defined direction. Used to only work with hexahedral meshes, now works with tetrahedrals. And so, and then as far as the other manufacturing constraint, you're talking about casting or even additive, the level set deal, it can support a minimum thickness control. So if you're trying to keep it producible,
that's important because sometimes the level set would come up with some crazy thin parts. So that's good to know.
Yeah. And the last one, the shape optimization, it's kind of taken away some control and introduced some program controlled. So again, this kind of relates to distorting the mesh, and how much is it allowed to distort the mesh? How much is it allowed to distort on an iteration to iteration basis or versus the total move? So that used to be, I don't want to say expert level, but you had to kind of pay attention to your meshing. You had to pay attention to, dimensions and that kind of stuff. So that's been, there have been some automated rules put in place for that.
Yeah, and it seems that it's coming up with what I would call dimples on some of the geometries because of that, adding that capability in there, it seems, which is, that's some serious weight that wasn't getting taken out before. It's kind of cool.
Yeah, it's definitely like, during the webinar, there was a question of like, when would you use one versus the other? And, it's essentially, one, the topology optimization, you're tied to the original like domain size.
Right.
Like, you're not going to grow outside of that. You're not going to add material. Whereas the shape optimization is just going to keep distorting the mesh. As long as everything works, it can grow in any particular direction.
Yeah, it does open up some new things. My big advice for folks that haven't looked, and I say this every time we talk, who haven't looked at topological optimization, which we're now just calling shape optimization, I think, is take a look again. Every release, make it better and better, right? Yeah. We looked at a third-party product recently, which we'll not name, but I think it was one of those things where 3 years ago we would have said, "Oh yeah, we can't do that." Now we're going, "Yeah, most of that we can do now."
Right, and each release, like if you didn't like it, a year ago, like we probably addressed it. And talking about things that change from release to release, the kind of last topic, and what I'll now recommend for everyone doing any type of topology optimization on the validation side of things.
Right.
So the one thing that is that Ansys doesn't do is you can't really look at stresses on the optimized shape in the topology optimization. So
right.
It just, the way that we, discretize it, the way that we use shape functions, the way that we use kind of either pseudo densities or turn elements on or off, it's one of those where, you should really be running a validation off of the geometry. And so, the method that you go through, whether I'm using, an STL output or actual geometry, it's essentially been changing each rev. And it's something that, if you look in the documentation and kind of follow the instructions, it should get there. And obviously, if it doesn't, you wouldn't be the first one to ask a tech support question on that. But, at 2021 R1, the workflow to go from optimized shape to optimize, convert that to geometry has changed a bit, and it's primarily leaning on the auto skin feature, and we're talking now about a feature within Space Claim.
Okay.
And so it essentially allows you to take, you essentially have your Jello, you got your optimized shape that's embedded in your original structure, or your original starting block, and then the auto skin essentially does an auto trimming routine in order to create actual geometry from the STL output. So
that you can then mesh.
Yeah, you can then mesh. You could take that anywhere you wanted. Like it's you can export that as Parasolid, ACES, any wherever you want to take that, whatever you like to do with CAD geometry, have at it.
If you're not the CAD, that's a really good point. So, I think in the past, what a lot of people would do is pass an STL to their CAD person, right, and say fix it. Now you can use the auto skin and send definitely a better starting point.
Yeah, it's I'm sorry, like that's one of those where it's like not appreciating what it takes to turn either scan data or STLs into geometry. It's like, oh well, this should take you 10 minutes. It's like, oh,
I wish.
There are tools that help with that, and the auto skin is one of those. But yeah, I mean, there's always a little bit of artwork, a little bit of experience that goes into that. So the workflow, like I said, changes from rev to rev. review the instructions to see, what needs to be connected to what on the project page. And obviously, if you have problems, contact your support provider.
Yeah, definitely. Well, very cool, and lots of good stuff in there.
Yeah, this went longer than the 10 minutes.
Yeah, we thought
we talked about.
Yeah, we were beforehand. We were kind of like, okay, this will go really fast, and then no. The more we talked about it, the cooler the stuff is, right? Because it's if you list it out, it's not a lot of bullet points, but each bullet point is kind of a big deal. So, yeah, I like it. Well, always appreciate your time, Doug.
Yeah.
And everybody do check this out. Just do check out if you want to see some of the pictures and stuff. Do the recording on our webinar, the last one that we did, and we hope to see more. This is just 2021 R1. R2 is going to have cool stuff in it. We'll talk about it then.
Yeah. I mean, we didn't talk about the beta features. There's some good stuff coming to essentially all aspects of it. So and kind of the roadmap even further out looks pretty promising.
Yeah, there's a lot of effort going into this, and definitely keep up with it if you're interested. All right, well, thanks, Doug. I'll let you get back to work, and we'll talk soon about something else.
Sounds good.
Thanks a lot.
All right, bye.
As was mentioned, when we looked at the list of new things, we didn't think it'd be a very long conversation, but when you get into each of them, they're all pretty significant. So I think we covered it all. I'd like to remind everybody that you can get more details on what we talked about in the release notes. Always recommend reading those, or by going to brighttalk.com and searching for PADT and register to watch the recording of Doug's webinar on this topic. I'm going to do a very quick commercial today. If you need additional resources for your simulation, please consider PADT. Structural, thermal, dynamics, nonlinear dynamics, fluids, low-frequency electromagnetics, high-frequency electromagnetics, systems, of course, multiphysics. All of these are the things that we do as a service for other people. So please reach out to PADT at info@padtinc.com and let us create a proposal for any simulation work you're considering outsourcing. I think you'll be very happy. Many people are. So join our group of customers in that area. Let's take a look at the Ansys stock. I did this early in the morning, so the market had not closed, so these numbers may have gone up or down, but it's been a bit of a roller coaster since the last time I looked, but it's been mostly up right now, again, which is early in the morning. It was sitting at 351.85. That's much better than the 293 on March 8th, but still not back to the all-time high of $413.19 in February. It's been a full quarter actually, and so it's probably a good time to look back at how Ansys is doing in comparison with the S&P 500 as well as other stocks we look at in the sector. So the S&P 500 is up since the beginning of the year, since January 1, 7%, 7.02 to be precise. And Ansys is actually down since the start. It started quite high at the beginning of the year, so it's down 3.28% again this morning. In the group that we usually look at, PTC is doing the best. It's up 20% year to date. Altair is up 8.83% year to date, and Autodesk is also down along with Ansys, 7.02%, which is, ironically is the exact mirror of how much the S&P 500 was up at the time. Again, it was 9:15 Pacific on April 2nd, so do check and see what happened the rest of the day if you're very interested in that sort of stuff. But it's recovering from that lowness. The economy's picking up, manufacturing's picking up, employment is picking up. So we'll see if the market defies common sense and a product like Ansys, which should do well in a situation like that, goes down, or if it goes up as well. I don't have any news from Ansys themselves. They're in a quiet period right now while they're looking at the end of the quarter. We do have some news from PADT, which will be announced officially sometime around the time this podcast comes out. So the big one is that we are a EOS reseller now. So it's not Ansys related. If you don't know EOS, they're the leading laser powder bed fusion 3D printing solution in the world. They're a German company, and we now sell it in Arizona, California, Colorado, New Mexico, Nevada, Texas, and Utah, as well as a few other states along the border of those. So if you're in one of those states and want to know more about why we feel EOS, why we chose it as the technology we use in-house and that we now sell, please do reach out. So again, that's EOS, metal laser powder bed fusion systems, and pretty much across the Southwest, same areas that we sell Ansys in pretty much. We've got some other announcements that I was going to bring up, but I think we're going to wait till the press releases come out. They're not necessarily hidden, but I don't want to steal any thunder, so I'll wait for those other two as time goes by. Ansys blog-wise, the 3 articles that I liked. A while back, Ansys got involved. I don't know if you remember reading it or hearing on the podcast that Ansys was supporting some electric plane racing efforts. And one of the teams, a Swiss team that is participating in the Air Race E-Challenge, did an article on the blog, how they use Ansys to win. It's called From an Idea to an Airplane, how one team is rising to the Air Race E-Challenge. And it's a great overview of applying Ansys technology to what I think is going to be really cool and fun to watch, and will move the electrification of aircraft forward as well, as racing often does. Staying in the air, the next article that I picked was how to quiet drones with acoustic simulation. So one of the things I don't like about drones, multi-rotor drones, is they can be really loud, right? They get a lot of interference from the turbulence from all those little propellers. So this looks at how you use CFD, aeroacoustics, so in Fluent doing the acoustic simulation, along with VRX Experience Sound. So that's our ability to take the profile from the CFD simulation that says this is what the sound looks like mathematically, put it into VR Experience, and you can actually hear what it sounds like. So not only can you reduce the overall decibels, but it may be an annoying sound, which is true of a lot of these drones. So it's pretty cool application of that. It's a great example of using multiple Ansys tools to get noise reduction in place. And as we go more and more into electrification, we have more and more of these sound problems. So do check that out. And the third choice, I'll have to be honest, I'm going to be a little selfish and promote my own post in the Ansys blog. So they were kind enough to accept one of my posts. It's called Create Your Minimum Viable Product Using Simulation. So MVPs using simulation. And in it, I talk about what an MVP actually is. Most people think it's one thing, and what it really is a little bit different. And how you can use a virtual prototype, a digital MVP, to get to market faster and then better products as an end result. One of the things that we talk about a lot in the startup community is in the software side, it's kind of a given that you create an MVP of your product so that your customers can test it and you can improve the product very quickly in these very fast iterations. We don't tend not to do that in the hardware side of things because we got to build the hardware, and that takes too long. And by the time you get feedback from the customer, you've already committed to manufacturing. So the whole premise of the article is create a virtual prototype and let your customers test that and get feedback on that so that you can affect your design before you commit to manufacturing. So do take a read on that, share it with other folks, especially your management. I think it is an amazing application of simulation that can really make a difference. We did publish that on the Ansys blog, but we didn't publish anything new on the PADT blog, so nothing there. Event-wise, our next webinar is on thermal integrity updates in Ansys 2021 R1, and that's going to be on April 7th at 1 o'clock Mountain Time, or actually Phoenix time. It's a great topic to talk about thermal integrity. Then I'll be hosting the next Arizona Tech Business Networking event. It'll be our 13th, so lucky 13 or unlucky 13, whichever you prefer. So if you're interested in or part of the Arizona Tech community, please do show up for these fun. This is our 13th one, so they're kind of fun events. That'll be from 5 to 6:30 on the 15th in the evening. And then the most important event coming up is Ansys Simulation World 2021. Last year was a blast. It was a great event. This year we'll be doing it again. It's on the 20th and the 21st. And please do go to our website and hit the events button and register from there so that we get credit for your registration. We appreciate that. And then also, if you're in Arizona, we will be putting a team together that's actually going to be pretty good for the 11th annual Tucson Golf Tournament. I will not be participating, but Tyler Shaw, our new VP of Engineering Consulting here at PADT, as well as Kang from our manufacturing department, are both pretty good golfers. And then we roped in 2 customers from Freefall Aerospace to be on our team together. So if you're in Tucson or in Arizona at all, and you want to do a social event where we can be outside and be safe, please do sign up for the golf tournament this year. And that's going to be on the 23rd down in Tucson at a great course, beautiful course. And that's pretty much it for Ansys related activities that people would be interested in. And we've got some 3D printing stuff coming up, as well as more webinars. So do check out our events page on our website for more information on that. Another way that you can keep in touch with what's going on in the world of PADT and Ansys is to subscribe to our newsletter. So if you go to www.padtinc.com/opt-in, you can sign up for what you want there. I do want to thank everybody once again for listening to our podcast and being part of our journey. In the last year has been an interesting one. It's great to be back in the office. Please do spread the word to folks about the podcast. Subscribe to the podcast in your podcasting program of choice, and do not hesitate to reach out. And again, appreciate your time, and we'll talk to you very soon. Thank you for joining us for the All Things Ansys podcast, episode 85. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only, and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.